Hello, my name is Indradhanush Gupta and I'm a software engineer at Kinfo. Today I will be demonstrating the Habitat Service Broker. The first prerequisite of a Habitat Service Broker is a functioning Kubernetes cluster with RBAC enabled. We will be using Minikube to demonstrate this locally. So let's start our cluster. Now that our cluster is up and running, we will now install the next prerequisite, the Habitat operator. Now that the Habitat operator has been installed, we will install the service catalog, which is a wrapper around the Open Service Broker API. This can be installed using Helm. The service catalog is installed under a namespace called catalog. So let's verify if the service catalog has been installed. Now that our final prerequisite has been installed, we can now move on to deploying the Habitat Service Broker. But before that, let me tell you about the svcat command line tool, which can be used to interact with the Open Service Broker elements present in the Kubernetes cluster. At the moment, there are no brokers installed. The broker is installed in a namespace called the Habitat Broker. We can see that the Habitat Broker is ready. We can also verify using the svcat command. We are waiting for the broker to be in a ready state, after which we can start using it. Now that the broker is ready, we will take a look at what are the available applications that we can install using the broker. For our demonstration, we will be using the Redis Habitat app. We will create a service instance of the Redis app. To do this, we will apply the following manifest. Now we can take a look at the instance using the svcat command. This will also start a new Kubernetes pod. Once the Redis pod has been created, we should be able to use it. Although the Redis pod is in running state now, we cannot yet use it without creating a binding. The binding will create a Kubernetes secret object which configures Redis to be used with a password. Currently, there are no bindings installed. To install a binding, we will apply the following manifest. The binding is now ready for use. But before we can log into the Redis server, we need to know the authentication password. This information is stored in the secret that was created as a result of creating the binding. The secret that we need is called habitat OSB Redis and a random string. So let's take a deeper look into what's inside this string, inside the secret. As you can see, the data part of the secret contains a key value pair. This is used by Habitat to configure the pod. The value of the user.terminal key is a base64 encoded string that is directly mapped onto the Redis configuration. We will now decode this and see what is the content of that. Now we know the password that is required to connect to the instance successfully. We will use this password with the Redis CLI which has been installed before the demonstration. But to connect successfully, outside the cluster, we need to expose the Redis instance as a service. We will apply the following manifest for that. As you can see, we can connect to port 30,001 on the Kubernetes cluster to connect with the Redis pod. We need to get the IP address of our cluster. We will use this to connect. Oops, we haven't applied the service manifest yet. So let's do that. We should be able to connect now. We will now use the password obtained from the secret to authenticate ourselves. Now that authentication is successful, we can use the Redis instance. We will now delete the pod. Since this instance is being managed by the operator will ensure that a new pod is placed in place of the deleted pod. We are using persistent volumes, so we expect our data from our previous session to be found even after deleting the pod. Let's verify that. As you can see, even after deleting the pod, the data has persisted. We will now remove the binding, which will prevent us from accessing the Redis instance from outside the cluster. As you can see, the binding has been removed, and so has the secret. So let's try connecting with the password that we used last time. As you can see, the connection has been denied. With that, we come to the end of this demo. Thank you for watching.